Newton's method for approximating roots. Our goal here is to find the approximation of this root of this function. We're going to do this using calculus. So we start off with some x value, and we're going to call this our initial guess. So that's going to be our initial approximation. What we're going to do is come to the graph, go up to the graph. That is a point, x sub n, y sub n. We could start off by thinking that is x sub 0, y sub 0. But I'm going to try to derive the general case now. We draw the tangent line. Look at where the tangent line hits the x-axis. Compare that to our original guess and the root. This tangent line is now closer to the root. What can we do at this point? Well, this is going to be our next value. What's the coordinates of this point? It'll be x sub n plus 1, comma, and the y value is 0. So if this was our first guess, x sub 0, then this will be x sub 1. What are we going to do from there? We'll go straight up to our curve, and we'll draw another tangent line. Which is even closer to our root. This value will be x sub n plus 2, and then comma 0. And we would continue to draw the next tangent line, etc. This one will be a little bit harder to see, but you can see that's getting pretty close to the root with just a couple iterations of this process. Now let's see if we can derive an equation for this. We have the tangent line. That would be this thing. How do you find the equation of that line? Well, we need a point. We have a point on the line. That's x sub n, y sub n. And we also need a slope. What's the slope of the tangent line? Well, that's going to be the same as the slope of the curve at that point. That's our derivative. So we'll have y minus y sub n equals f prime. Now, where are we evaluating that derivative? We're going to be evaluating at that same x value. So f prime of x sub n times x minus x sub n. Just so we can have it all in terms of f, which is what we're going to want to go to, what we're going to do is say let y sub n equal f of x sub n. We're just going to use that. Now we need another point on this line. What's another point? We can see here that it crossed down there. So we have this point on the line, xy, and that's going to be x sub n plus 1, comma, 0. Now since it's on that line, if I plug it into the equation, it must satisfy, it must work inside that equation. So let's plug, first of all, let's change y sub n to f of x sub n. So we'll have minus f of x sub n. And we still have our f prime of x sub n. And then we'll have x minus x sub n. Now the point is x sub n plus 1, comma 0, and we're substituting that in for the xy values. Here's our xy values. The x is x sub n plus 1, and the y value is 0. At this point, what we want to do is we want to find out what is x sub n plus 1, so we need to solve this equation for that variable. The first thing to do would be to get rid of this derivative f prime of x sub n. So we'll divide both sides by it. So we'll have negative f of x sub n divided by f prime of x sub n. And that will equal x sub n plus 1 minus n. Now in order to solve this for x sub n plus 1, we'll move the x sub n over to the other side. And we'll get x sub n minus f of x sub n divided by f prime of x sub n. And I wrote the wrong thing there. F prime of x sub n. And that will equal x sub n plus 1. Now, so what does this mean? This means in order to find this next guess, the next approximation for this root, I can use everything from my initial one, from my previous guess. So I need that value, then I minus the y value of that and the derivative. And that is what we are going to use. So let's look at an example. Number 1, y equals 3x squared plus 2x minus 3. Now I picked this one purposely because it's not factorable. Let's take a look at a sketch of this. And it will look something like this. Has a negative y-intercept. Now we want to be able to find these roots. And this is 1. And this would be -1 and -2. All I'm doing is just plugging in some numbers there to get a feel for it, because if I plugged in 1, that would be a 2 up here. Plugged in -1, that would be -4. And what are we going to need now? We're going to need the derivative. Y prime will be 6x plus 2. Let's find the positive root. Now you could use your graphing calculator to find the 0. You could also use the 92s to just solve it. We get that the positive root, I'm just going to write it down so we have something to compare to, 0.727592201. So our goal is to get that using this Newton's approximation. You have to be able to do this by hand. So while we'll end up using a calculator to do some of the calculations, you need to be able to do the first few steps by hand. And so that means you need to practice your fractions. We need some initial guess. It's not so important as long as it's somewhere close to it. We want to, how about let's pick x sub 1 equals 1. We'll start off as our first guess. If I started over here, let's say at -2, that would zero in on this negative root. And we want to find the positive. So our formula will say x sub 2, that'd be x sub n plus 1 part, equals x sub n, which is our x sub 1, minus f of x sub 1 divided by f of x sub 2. Sorry, f prime of x sub 1. So we have 1. What is f of x sub 1? We already did that, plugged it in. That's 2. If we plug in 1 into our derivative, we get 8. So this gives us 1 minus a fourth, 3/4. So that is our next approximation. So it's a little bit closer to this. Now let's find x sub 3. X sub 3 will be x sub 2 minus f of x sub 2 divided by f prime of x sub 2. What is x sub 2? That's what we just found. That's 3/4 minus. So now what we need to do is plug it in to the equation. We're going to find 3/4 squared plus 2 times 3/4 minus 3 divided by 6 times 3/4 plus 2. So if we did this one, I've already done it. You need to be able to do this calculation by hand. What you get is 3/4 minus 3/16 divided by 13/2. So we get 3/4 minus 3/104. So we can get a common denominator and multiply by 26, and we'd get 75/104. So now let's take a look at a calculator. see, I typed it in there as well. You could do something like that, and you get this number, 0.7211538 And let's take a look at what 75 divided by 104 is. It's the same thing. So that is it pretty much for doing Newton's method by hand.